Hello everyone, I'm Mona Lisa, I'm architect, institutional manager here at Zigurat. I'm feeling to be here today. I'm happy to be here today alongside these two incredible teachers representing Zigurat Institute of Technology as dive into the exciting world of cities, infrastructure, and technology. Okay, so first up, let me introduce you to Jun Lee. She's not only our GIS project engineer and developer at Kier Group, but also a professor for Zigurat's Master in Global BIM Management and Civil Engineering and GIS. And we also have Guillermo Corral. He's urbanist and project director at 360 Smart Mice and also a professor for Zigurat's Master in Global Smart City Management. So thank you for being here today, Guillermo and June.
Thanks very much.
Thank you. So Zigurat has always been committed to nurture the professional development and personal growth of individuals with the construction industry and the built environment. And our mission is all about empowering people to take the complex challenges and ever evolving demands of this dynamic sector, all while working towards for a brighter future. So let's kickstart the transformation and make tomorrow happen today with Zigurat. And let's see what happens when an urban planning meets a GIS expert. So Guillermo, can you share with us your screen?
Yes, sure. Thanks, Mona. So I will share my screen to get into the presentation. Okay. Okay, so we'll start here. So first of all, we will define these two concepts of GIS and urban planning. So June, if you shall start explaining what GIS is for all of us. Sorry, I think we don't listen to you now.
Oh, can you hear me now?
Yes, you were muted there.
Okay, perfect. Yeah, that's the issue with technology, isn't it? So what is GIS? So GIS is really short for Geographic Information Systems. And there's a lot of definitions out there that are quite evolving over time, but my personal favorite is that it's a system of computer hardware, software, and procedures that are designed to support the capture, management, manipulation, analysis, modeling, and display of spatially referenced data for solving complex planning and management problems. And this definition is from the US Federal Interagency Coordinating Committee in 1988. And now it's no longer so constrained with the technological development. And of course, I think you can use GIS for pretty much anything to provide informed decision-making. And with the changing technology and semantics, the definitions of GIS are also changing.
So on the other hand, I guess urban planning is more an analogic discipline. It's true that it doesn't start until the 19th century with the first urbanists, because as far as then, it was architecture and urban design, which is basically related to the physics of the city, when urban planning arises and it distinguishes from the physical condition of the built environment in also considering social, economical, and cultural constraints. And in this regard, we can say that urban planning sets a short-term, mid-term, and long-term vision for the development of the city. And of course, all urban planning regulations that are set and approved have to be or must be followed by any city in particular, and the authority that can be local or national that is involved in the use of land and development. As we will see in this presentation, we will be mainly focusing on land use planning, but there are other ways of planning that we also explore in the master courses of Zigurat.
So I'm going to touch upon GIS in a more simplistic manner in real world terms, because it's quite a complex topic in an hour's time. But I'll divide it by first data collection, and then second spatial analysis, and third interpretation and decision making. So before you even collect data, we have to understand the context of what we're working with and what we're interested in. So GIS is a very powerful tool that can be used in many different disciplines to answer questions and really solve problems. So when we collect data, this can range from a lot of different types of data and data procurement methods. So it could be field data collected by construction site workers or surveyors that take ground truth information. Could be remotely sensed imagery from satellites, or we could also have LiDAR data from drones. So this means there's a plethora of data that we can actually work with. Next. Then we have the spatial analysis, and analysis is carried out by utilizing the said collected data for our context. And for example, if our goal was to find out the suitability of agricultural land, let's say, based on scientific community research and standards for agricultural plots, we can use data about, for example, land cover, soils, slope, distance from streams, and distance from roads to identify, based on certain metrics and criteria, on how suitable agricultural land is for each types of data, and then combine it to obtain an overall suitability map that are evaluated against 4 different criteria of the highest to lowest areas that are suitable for agricultural land.
This is actually really useful for planning. And actually I want to make a comment just to compare both disciplines, because when we were preparing this masterclass, we were commenting with Yun that all that you see in the screen for a GIS developer or specialist is like the final stage, because it's the outcome, right? Because it's when you have all the information displayed. And for an urban planner, this stage of spatial analysis and context is an early stage. So for planners is really, really crucial. And it also has a lot of potentialities to have all these final results from GIS, because it does inform our profession. It does support our decision making, and it does help both the public and the private sector. Because if we speak about a local authority that is developing a new planning policy or is designing its new development plan, all of these suitability layers and also the weighted value of each of the layers will inform planning. But also, if we are talking about designers and developers that are deciding to invest in a particular plot of land, or they want to propose a new development, a new scheme, including many uses, or even a park, or even deciding the do-nothing scenario. All of those considerations have to be informed, and this is a way of having let's say every layer compiled in just one software. So from a planner, we really appreciate that we can get these kind of outcomes. And actually, I was talking about decision making. This and the next slide, and actually apologize for the spoiler I did at the beginning, but these are really powerful and also dramatic images, and they are really important for me because they are about my hometown in Spain, which is Zaragoza. This is not, we are in Spain in this image. We are not having a tropical climate at all. We are just having a Mediterranean dry climate, but it's true that with climatic change, we are experimenting harder rain effects, especially when we are talking about heat waves that, as I say, they developed into this kind of phenomenon that especially happened in the afternoon or the evening. So this happened actually last Thursday. And this is an image of a road belt. So this is a key infrastructure. And as you can see, it was heavily used at that moment because this was the afternoon. This was the moment of getting back home from work, for example. And this collapsed. So this is just exemplifying a bad planning decision, because there was a planning decision saying that a road had to go in this embankment, which in the past was a water flow. Usually is dry, but that doesn't mean, and actually geographical information was showing that, but that within a 20 or 30 year period, water could flow in this area. And also another example in the same area, this is a school that was also built within a water flow that, as I said before, is temporarily dry, but can be can receive water in certain periods of the year, and also in rainwater events. And the school was also decided to be built in a particular location. As I say, this is established in a development plan, and therefore, if there were suitability maps, they were not well evaluated, or, which is the consideration that I have, there was a lack of suitability maps, and there was a lack of a GIS system such as the one that June was explaining before. And this is the result, actually. So this is really concerning, and it shows the importance of applying GIS in urban planning.
So with that, we can see that location information is really important, and the analysis, because people like Guillermo, who is an urban planner, can utilize this kind of information to help make decisions or even make recommendations with informed information with informed data and analysis. This is another scenario of a spatial analysis, and it's a scenario where a retail store has been successful, and they want to open a second store and want to determine the best location for the next store. You can evaluate predicted sales by using controls like travel time, population, income, and age. And with this scenario, it was upon a statistical analysis, they found that age was actually not a statistically significant indicator that influenced sale values. Now, with the model and predicted forecasts of sales in the region, it can be compared to actual sales. So it uses information about the relationships between different locational characteristics to apply that knowledge on predicting sales at a new location or a location that they want to build at, allowing for informed decision-making on whether it is a good idea to open a store or not.
In this slide, actually, Yoon is highlighting 4 layers that are weighted, and they are particularly relevant when making this particular decision, which are travel time, that we can fully translate into the 15-minute city, which I think the audience will be now confident with this term, and is basic for urban planning at the moment. We are highlighting population, which is equal to density, that has been a key factor historically in urban planning. And then we are talking about other indicators such as income and age, which are considerations from the socioeconomic and cultural part of the city, which is crucial. And actually, in the global smart city management, we evaluate the consideration of socioeconomic indicators and its influence in urban design, and how urban design and planning decisions impact on these indicators. So it's basic to consider those in urban planning, and we see that there is a key relationship between socioeconomic indicators and urban planning, and this is something, as I said before, that we explore further in our master.
Yeah, and I really like the point of the whole social economic indicators, because in spatial data and in location, these are quite important. So let's say we can even understand green spaces in the context of the urban environment. So here, the left it uses GIS-based spatial analysis to determine the accessibility of urban green for different racial groups and for different cities in the States. Now, they examined that relative racial vulnerability of census block group and zip codes, so in neighborhood information, areas to COVID-19 green space distribution at different scales. So they ranked the racial vulnerability against the percentage of available green space for each city. And the results really showed that the legacy of past and present urban planning injustices are visually displayed. And this kind of information is really useful for things like environmental justice or urban planning, different perspectives of urban planning, or public health management, or different kinds of social policies. And in this instance, they concluded that pandemics like COVID really highlighted different gaps in placement of urban green spaces. And in return, it shows inequality in these spaces regarding access to and both the availability of different amenities, which during COVID time was important for people to get out and see, a forest or have something to do. And discovered that there are disparities in distribution in all 4 of these cities, and actually found people of color experience disproportionate impacts. The picture on the right is also on urban green space. And it's also based on accessibility, but in Brussels. But this evaluation is more centered on the data that was utilized to understand the spatial distribution of urban green spaces. So they found there are strong differences in value of indicators when using different data sets, especially due to different ability to capture both private and public green space based on what kind of data they utilize to make a visualization and representation. So you can see that it's quite important to also question what kind of data you're using to produce outputs and spatial analysis, and important to control for these different data sources.
And actually, if we are looking at the right-hand side, which is the analysis from Brussels, if I was the head planner of Brussels, I would say, according to the map in the middle, which is the dark green, the dark green predominance, I could say that my city is amazing because it's all green and it's full of green spaces. But if you look at the legends, all dark green spaces are private. So from a planning point of view, is not saying that the city is succeeding, because most of what we see there is not in the public realm, and therefore is not helping people in the purpose that June was saying before. And that's why it's important for planners as well to have a good data reliance. And especially if we are talking about decision makers that elaborate on public policy, we need to be certain, and we need to be in the purpose of being human-centered. We need to be reliable, and we need to have accountability of the decisions we make. And therefore, that's why data, in the way that we use it and in the way that we also display it, as you will explain further later, is key for urban planning.
And that's regarding the whole context of why it's important. See, with data, whatever data you're using, the context of using that data is important. And as Guillermo said, the middle map, there's a lot of private green spaces that they were able to capture from this data set, versus the other two, difficulty in capturing private urban green spaces. So at the end of the day, the context of what you're trying to look at, whether it's a question that you want to answer or a solution to our problem, you have to understand exactly what the requirements are and what we're looking at. So these are really important because it really helps us to fuel decision making, which is the next slide.
Yes, exactly. Here we are going to present now different examples of how the relationship or the junction between GIS and urban planning happen at the minute, and because these are real examples that can already be used and they can be visited. So the first one is about Helsinki, the Energy and Climate Atlas. This one is focused on, as the name says, energy, so it's not a complete, let's say, digital twin, okay, which is a further elaborated concept which talks about the representation of, in this case, of a built environment in the cloud, in virtual reality. But it's a really useful tool because it identifies or it gives data about the buildings of the city. So we can say that we are also talking about building information modeling, which is basically buildings modeled in its geometry, so in 3 dimensions, but furthermore, as building information modeling does, it provides information about different layers of the building. And in this case, as we say, we are talking about energy information, we are talking about the heat savings of buildings, we are talking about sunlight daylight as well, and we are talking about CO2 emissions. So this is a really interesting tool for all stakeholders to apply. And also, of course, not forgetting GIS, this is actually a city information modeling tool, which implies that all the information is geolocated as it is in a certain geography in a certain built environment. This is useful for the existing built environment management, so decision makers in the city, but it's also useful for other stakeholders such as private companies or designers, for example, an architect that wants to retrofit a particular building, or a developer that wants to build adjacent to a singular building, and therefore the impact, not only in the particular plot, but in the surroundings, can be assessed by this tool. If we go to the next example, the previous one, by the way, is the Helsinki Energy and Climate Atlas. If someone is interested on looking at it and navigate, it's a public led project, while this one is led by academia because it's led by the MIT in the United States. This is the Cambridge area in the Cambridge town in Massachusetts. And I highlight that it's developed by academia because many times when we talk about the different stakeholders and the actors that intervene in the planning process, we basically talk about private and public, and we forget about society and academia. And maybe even if we consider them in an innovation framework in which the 4 of them are considered, we think of them as passive actors. However, they can also be active. For example, society can be active in bi-directional decision making, and also in giving information for these platforms in, for example, the performance of the buildings. And in the case of academia, they can research and develop frameworks like this that, of course, have a clear transference to society and to both the private and the public sector. And what I want to highlight of this image is that it clearly informs decision making, because if you have a look at the legend, the colors don't talk about particular information of the buildings, but cumulative savings of energy of the different colors. So this means clearly that if we just address energy retrofitting of the red buildings, which as you can see, they are really few, we can achieve a saving of a 20% within the overall city. And if we join red and yellow, we can achieve a 40%. And as you can see, yellow are not so numerous. So it focuses the priority of where to intervene, in this case, in energy performance and in, of course, climate action within our cities.
So with the previous slide, I think it's really nice to see all those visualizations because it's quite aesthetically pleasing. And with GIS, that's really one of the final steps, is visualization of data. Because if you see here on the left, it's a ArcGIS dashboard that's fueled from location data from all over the world, and it informs many different kinds of viewers. And to the right side, we have scene layers, also an ArcGIS platform, of 3D models. The top right is an infrastructure, the right and below are utility data. And this kind of information is important for people like stakeholders to be able to interpret and understand the data. And it's important to also set the data up in a way that is easy for people to understand and to really relay the information that you want your viewers and your audiences to be able to see.
We actually have to imagine that all these GIS outputs or outcomes are going to be used by many stakeholders. We can talk about, if we just focus on the public sector, we have to think that we can within the staff of a public authority, we can have multi-generational teams that they can have a great planning expertise, but they have new background in GIS and they are not interested in the software development, as for example Joom can be, and they are not they cannot use this kind of software. They just want to visualize data and take decisions. So we have to think in that kind of people. On the other hand, also in the relationship between the public and the private sector, if we look at the images on the right, which are more related to building information modeling, at the end we are talking about languages. So GIS can be understood as a language because it's a way of communication between different practitioners regarding a certain geography. If we talk about building information modeling, it's also a code that can make different actors in construction and architecture and engineering understand between each other. So these languages have to be clear and usable for the majority of the stakeholders, regardless its condition, expertise, or even generational factors. And in this case, for example, in Spain, the local authorities leveraging, or well, the public sector in general is leveraging the usage of BIM, which will also feed in the city information modeling and digital twin approach of urban planning. However, the public sector still does not have the means and expertise to use BIM, while the private sector does have, because they have already been using building information modeling for at least 15 years. So it's important to consider those constraints and many more, and also think that all these visualizations and even information from certain buildings in a city strategically located or with a strategic function also need to be displayed for the public, especially if we want community engagement and cities in which people can participate and take their own decision in terms of city development, urban planning, etc. So finally, we are just gonna conclude this masterclass from June and myself in explaining that GIS is a supporting tool for urban renewal, which at the end of the day is the main objective that planners have, which is the health of the city and which is making cities better for people that inhabit them. It's true that, and I have to say, we are speaking globally here and the masters are also speaking globally, so we try and address the trends that are happening globally, and I understand that in many regions of the world we are in kind of other trends that are also related to expansion, although all these benefits can also be related to expansion schemes or development schemes. But in this case, and is something that we focus on the smart city course, because as it is a complex environment, we try and show how technologies help to intervene in complex built environments, because at the end it's much worse to deal with a complexity of a built environment that is already there. We also have natural constraints, etc., etc. So what you are seeing in the screen is the transformation of Bilbao that happened 20 years ago, between 20 and 30 years ago. It's a major transformation because it involves the transformation of an industrial area that was not, that became to be infra-utilized, and both politicians and planners had a vision, a long-term vision of a new cultural, magnetic, attractive area, which is the context of the Guggenheim that is internationally well known. And as you can see in the image of the right, all this planning and vision was materialized in the way that we see in the screen. However, they did not have the tools that are now available in the market, which, as you can see, is not just about computer-assisted design or computer-assisted drawing in which we can model in 3D. It's not just about that. It's about including all the information of the city in its different layers, in different ways of visualizing it, and also for different stakeholders, both for the inner public sector, but we can talk about stakeholders from the private sector, designers, developers, users, etc. We can also talk about citizens. This is also talking about accountability of planning, in which citizens can see exactly where the city is going. Also, we can talk about, and it's something that in the smart cities is an interesting topic, which is to make a city more attractive for international investment and also for attracting new talent. And it's also related to academia, because academia can help in the research and also in the development of this kind of tools. And I will just finish with this image, which is a compilation, an example that compiles all the information that we've talked about in this masterclass, which is the digital twin of Singapore, which is recreating exactly what is happening real time in the city. And therefore you can see an example of different layers, even real-time images in photographs, Internet of Things, and other technologies that are applied in the physical built environment. And with the help of those technologies and a GIS platform, we can develop a digital twin in the cloud, in the virtual reality, which helps decision makers to take decisions with real-time data. And we could follow for many hours just with this example in Singapore, but we invite you to research more and visit our courses to access to all this valuable information.
Thank you, Guillermo. Thank you, John. Sorry for this problem with your name. We'll fix it on the recording. And thank you. It's amazing presentation. I think that we have to build not just attractive cities, but helpful, health, and I think that we have to this challenger for the future. So thank you very much. I would like to invite our advisor Dimitrios to speak briefly about these both master programs, and then we are open to questions from the audience. Okay, so Dimitrios?
Yes, can you hear me?
Yeah. Mm-hmm.
Thank you very much, Mona Lisa. Thank you, Guillermo. Very interesting presentation, very insightful information from smart city projects and the workflows that are being followed in this. Now, in the next few minutes, I'm going to present you with the basic information in regards to the two master programs that Ziggurat is offering, in regards to which the context of the previous presentation was based on. And these two programs are the Global Smart City Management and the Global BIM Management in Civil Engineering and GIS. Of course, we haven't talked in the presentation about anything about BIM, but GIS, which is one of the tools that we use in this master program, is being used also in smart city applications. I'm also very excited since I can see that in the participants, we have some familiar faces, also some faces from my country in Greece. So I will be waiting for your questions in the chat box. Now, first, let's go first for the global BIM, for the Global Smart City Management Master Program. So the Smart City Management Master Program was created so we can provide professionals the opportunity to work practically in smart city projects, both in the strategic level, so they can learn how to participate in master plans, in strategic plannings, for urban regions, communities, even villages as well, how we can how they can participate in the strategic planning of this, also on how they can actually create a smart city application from level 0, from the idea to plan it, how to implement it, to actually design the application and present it in the end. Now to explain a few things about the structure, by the time you enroll in the program, you begin with block 0, which is the welcoming block. Here you have the preparation motivation materials, master classes, level up courses that will help you to prepare yourself for the starting of the program. The program is starting by the end of November 2023, and you will be starting with the first block, which is focusing on the strategic perspective of a smart city. Here you will be also able to see the different policies that have been issued by worldwide organizations like EU, United Nations, World Investment Bank, for the smart strategic development of modern settlements. You have the financing methodologies, the funding tools that we use in smart city projects, as well as the participation on how the end final users of these projects can participate in the data and decision-making processes of the project. Following that, we move to block number 3, where we have actually the application of the new technology combined with a concept of sustainability. So here we'll be able to see how all the tools that we use in smart city projects are being applied, through which inputs, what outputs to expect, which kind of methodologies we apply, agile, lean methodologies. And we're talking about tools like sensors, networks, BIM, GIS, digital twins, like it was presented before, smart city management platforms, and many more, actually. And we're closing the program with different examples coming from the different smart city development sectors, from smart housing, smart infrastructure, smart mobility, smart transportation, environment, energy, smart economy. We can actually explore smart city applications in every urban development sector that there is. Now, the program is time flexible, interactive. It's going to be 1 year in duration, of course, in English language. And with the completion of the program, you're going to receive the master degree from University of Barcelona, as well as a professional master certification from Ziggurat Institute. University of Barcelona is actually accrediting all our master programs as the public European university, which we're collaborating with. And in the context of this master program, we have also a collaboration with Amazon and IBM, providing you with access to their educational platforms, where you have additional materials that will help you in the program. Now, if you're interested to know more about the program, I would actually invite you to scan this QR code that you can see in the screen. You can put your information in the related form. So a part of my team can actually contact you and provide you with any information that you might be interested in. Just 2 points for this master program that might interest you a lot. In this master program, we actually we will be presenting big projects that are coming from the smart city industry, like the NEOM project in Saudi Arabia, or the Singapore smart city transformation project, which is actually one of the most famous smart city projects that have been completed and implemented already in the industry. Others are in different phases. Now, shall we move to the second program, the Masters in BIM Management in Civil Engineering and GIS? Here, this master program, of course, we haven't talked about BIM, but we have talked about GIS. And there are a lot of GIS professionals that are actually, today, they're actually combining GIS technology with BIM technology and BIM methodology. In this master program, which is actually one of the oldest, we provide the professionals the opportunity to learn how to work practically with BIM and GIS, how to apply BIM in the whole life cycle of a project, focusing on the managerial workflows with the related software and methodologies. Now, here again, we begin with block 0, the welcoming block. You will be focusing on, before the program begins, in some preparation. You have some software courses, some level up courses, master classes that you need to complete before we start the program. This program starts as well in the end of October, beginning of November 2023. You begin with the first block, which is focusing on the information management of the project. Here you'll be learning everything about the information management of BIM, how we can actually apply the different protocols, the different standards, how we can organize the information that we need, and that we will need during the implementation of the project. Following that, in block number 2, we focus on the integration with GIS technology. So here we'll be able to see how GIS and BIM are being integrated, how we can manipulate GIS through BIM platforms, how we can extract raster data, how we could actually construct the surrounding environment of the project using the digital terrain model. Following that, we move to block number 3, where we have the design phase. And here we'll be focusing on the design with BIM in 3 infrastructure categories. The 2 first are mandatory, and the candidate can choose for the third one. The first one is the roads and highways. The second one is hydraulic projects, drainage systems, and structures. And as a third category, you can choose between railroad design or water supply networks, sanitary sewer design. And after that, we move in the project controls, material planning, cost estimation, scheduling of the processes in block number 4, as well as how BIM could be used during the construction phase of the project. And we're closing with a phase of maintenance. And here we can also work practically with maintenance in the same infrastructure category that has been chosen previously on block number 3. A few words again here about the methodology. It's time flexible again, interactive for 1 year. With the completion of the program, you're going to receive the master degree again from University of Barcelona with 60 ECTS. Here to remind you that ECTS is the European credit system for education. It allows you actually to transfer your education in any country of the world. And this program is also been accredited by the Building Transformation. So this is the Canadian BIM Council. And they will be accrediting the program as well as providing you with a membership for 1 year, a free membership for 1 year in their organization. Of course, if you want to know some, here just to talk a little bit more about the software, because in contrary with the first master program in Smart City, which is a complete managerial program, here the BIM management program is a little bit more technical. So we're going to be using software, technical software. Here we have the list of the different software applications that we're going to be using, mainly Autodesk and Bentley. And we also provide you with 2 certifications, one coming from Autodesk and one from Bentley, since we're authorized training center from these organizations, companies. Now, if you want to learn more, the only thing you have to do is just scan this QR code. One of the members or me from my team will actually contact you and provide you with the demo for the program, for each of the 2 programs that you would be interested in, as well as any kind of information that you would be you would need.
Thank you, Dimitrios.
Thank you.
Thank you for that. So we can go ahead. I think that we don't have questions here on the chat just about the Ziggurat courses. So I think that it's all. We truly appreciate each and every one of you that are being here for all the assistance. And thank you, Guillermo. Thank you, June, for being here today with us. And all the recording will be sharing next week. And let's keep the conversation rolling. Thank you. That's all.
Thanks for inviting. Thanks all.
Everybody.
Thank you. Bye-bye, June. Bye-bye.